walk this way. You know Andy's good at work.
My mom took me take it.
All right, so why don't we get warmed up a little bit with these problems? I think that I forgot to mention to you on my website, there are some resources. You know how in there they've got boxes of resources? There's some opening of school things, and one of the opening of school things is the policy sheet, which you already have signed. But another opening of school thing is a list of math vocabulary, and it's pretty long. I can't remember how many words there are on it, but there are a lot of words on it. And you need to start familiarizing yourself with those words. Some of those words are the number sets and the properties. So let's go through these, and then tonight, take a look at that list of words and make sure that you know. I tell you what, I'll go through it tonight, and I'll make sure I tell you tomorrow. Remind me tomorrow to tell you which words I absolutely expect you to know by the end of this chapter, okay? There was some property work in the first couple sections. We didn't dwell on it a lot, but we probably should spend a little more time on these properties. And the number sets, we didn't go through it all, because I thought maybe you know, maybe you don't, so it's just good we're reviewing them a little bit. So here we go. What are the integers? Anybody know? What are integers? Someone said something, but I can't hear it.
-2, -1.
That's exactly what they are. Now, are you looking at the sheet, or did you remember that?
I looked at the sheet.
Okay. Well, yes, when in doubt, let's be resourceful. Let's look at the sheet. This is a set of integers. So if you were going to describe them, this is the definition, by the way. But if you were just trying to describe them to somebody over the phone or something, because I know that's what you guys talk about on the phone, integers. If you were going to describe those, how would you do it? What kind of numbers are we talking about?
Positive and negative.
Well, they're positive and negative whole numbers. That's a great way of thinking about it. Positive and negative whole numbers. There's no fractions in here, right? Okay, but there's positives and negatives. Those are the integers. What would we have if we took the negatives out? Does anybody know what that set's called? Those are the wholes. Those are the whole numbers. W-H-O-L-E. Anybody know what these are called? If we take out all the zero from back, anybody know what these are called? The natural numbers, sometimes called the counting numbers. Because when you were a little child and you learned to count, how did you do that? 1, 2, 3, right? They're called the counting numbers or the natural numbers. Good. Okay, what property is this right here? Pay attention. What property is that? Reflexive, that's a great property, but reflexive is exactly the same thing on both sides. So reflexive would look like x plus y plus z equals x plus y plus z. Reflexive means nothing has changed. Associative, commutative, it's one of those two. What's the difference between associative and commutative?
Associative is the parentheses.
Associative, commutative properties can, or commutative problems can have parentheses. Associative means regrouping has occurred. It means there are different things in the parentheses. In this problem, what is in the parentheses on both sides? Exactly the same thing. So the grouping hasn't changed. The same things are grouped. What has changed? The order. If you read this side, it's X, Y, Z. If you read this side, it's Y, Z, X. What's changed? The order. And when order changes, it is commutative. Remember, there is no N in the word commutative. So we're not talking about commutative or community or anything like that. It's the commutative property of addition, in this case, because we're adding. So fundamentally, come on, we're not gonna make this mistake ever. What's the difference between commutative and associative? Order is commutative. So when you read the letters or the numbers, if you're reading them in a different order, then it's commutative. If you're reading them in the same order, but they're just grouped differently, then it's associative. All right, what's this one? I know we talked about this one. What's this one?
Additive and
That's the additive identity. What's this one?
distributive.
Distributive. What's this one?
Additive inverse.
Not additive inverse.
Oh,
Multiplicative inverse. Remember when things cancel out, and that's what happens here, right? These cancel. When things cancel out, it's always an inverse property. In this case, we're multiplying, so it would be the multiplicative inverse. And this one, I just want to squeeze it in. You probably, some of you can't even see it. It looks like this.
Associative.
That's associative, because look, 2xy, 2xy, order didn't change. What changed? The grouping, right? So that's the associative property of multiplication. Is that ringing bells now, those things? Yeah. This first problem here, we spent some time on this. Could you graph this? This one here, could you graph it? What would that look like if you graphed it?
And then
Open where?
No, open at 4.
Open at 4,
Close at 3.
closed at -3, and shaded in between,
C.
right?
does it matter if you have the circles compared to the like parentheses? 'Cause, like, on the notes on the book, it had like the parentheses, but I didn't know.
As long as you know that means included and that means doesn't include it. All right, here we go. Now we're gonna simplify a bunch of exponents. Here we go. Answer?
Like,
-9. This one always trips us up for some reason, and you've got to just pay attention, because it's not hard. This is different than this. Do you see the difference? When you put an exponent on something, the exponent goes only to what it is directly attached to. So this 2 applies to the 3. It does not apply to the negative. This 2 applies to the negative and the 3. Do you see the difference? So the answer to this problem is -9. The answer to this problem would be +9. How about this one? Be careful, it's kind of the same thing. What does the exponent go with?
yes.
Only with the x. So this is 3 over x cubed. That is different than this. This would be 1 over 27x cubed. Can you see that?
Yeah.
This is this. The exponent goes only to what it is directly attached to. That exponent has nothing to do with this 3. This one does. All right, how about this one? Now we got a 2 on the bottom because we're going to cancel this way, right?
X
X
to the fourth on top.
X to the 4th on the top, perfect.
And then
Y.
Y4 on the
No,
bottom.
no, not Y4.
Y to the 10.
Y10 on the bottom. Because what does this negative exponent do? It comes down, and when it comes down, we have y cubed times y to the 7th, right? Which gives me y to the 10th. If we miss that, it's because we're careless. Let's be careful. All right, what about this?
15.
25.
Now, we got to be careful. Pay attention to this guy right here.
25.
What am I going to have to do first? Because of that, I'm going to have to do this first.
Yeah.
So I'm going to erase my properties over here. So that's going to be 25a squared b4.
Yeah.
And it's still times 3a cubed b. All right, so what's that going to end up being?
75.
75,
A to the fifth.
a to the 5th, b to the fifth. What do you think, kids? You all right with that? Okay, what about that one?
Flip it.
First thing I would do is flip it. Remember, these are the kind you can always do the lots of different things in different orders, but I would probably flip it first. And when I flip it, nothing changes except the exponent becomes positive. Now what? So what would I have on the top? And on the bottom?
9x.
Perfect. Everybody okay with that?
Yes.
Okay, this is more recent stuff here. We've got 2 points. What does this mean? Distance between them. This means the distance between them. It means the length of line segment PQ. Sometimes, by the way, that's written like this. Means the same thing. The length of line segment PQ. When we get to vectors, studying vectors, this is the notation we use with vectors. Means the same thing, the distance from P to Q. So how do we do that?
Square root.
Square root. So 1 minus 7 and negative 2 minus 4. You with me? So let me just do the arithmetic. So that would be 36
Plus 36.
plus 36. So that would be the square root of 72, which reduces to 6 root 2. Very good. Whoever said that, right on. Midpoint. Say 2 points from midpoint. How do we find the midpoint?
X1 plus X2.
We average. So 1 and 7 makes
8,
divided by 2.
4,
Negative 2 plus 4
2.
divided by 2. There you go. Easy. Now, having done those 2 problems, this is a breeze. We want to write the equation of the circle that has those points as the endpoints of a diameter. We talked about this yesterday, I think, or maybe the day before, I can't remember. What do you need to write the equation of the circle? You need the center and you need the radius. We already know the center is 4, 1, don't we? Because we already did that work. And we know the diameter is 6 root 2. So the radius would be 3 root 2. So we've got everything we need. So what's the equation of our circle? X minus 4, good, plus
Y minus 1 squared.
equals, not, it doesn't equal 3 root 2.
No, it's.
It equals 3 root 2 squared, which is 18. 9 times 2. Got it? Let's see what else I got on this gaming sheet. All right, what about homework? Any issues with homework?
Yeah.
I just all like, I didn't have any of it. What'd you put 3? I didn't do that. I got could be 3.
Oh, I was up to started.
Any issues with homework? Jessica?
Number 27.
27.
Good. Actually, yeah.
Yeah.
Okay, 27, here we go. All right, Jessica, what was your thought? Did you have an idea how to start?
Well, I started by multiplying everything by 8, and then I did the same thing with 2.
Okay. Multiplying everything by 8 is perfectly legit. It doesn't really fix what needs fixed though? If your intent is to remove the fractions. Now, that may or may not be your intent. It's always my intent because I hate fractions. I just don't want to deal with them. So if I can get rid of them, that's what I want to do. So if my intent is to rid myself of all the fractions, then I'm going to multiply not by 8, but by 24. That will clear every fraction out. Multiplying by 8 will take care of these two, but it's going to leave a fraction here, and I'd rather not have any of them. So I'm going to multiply everything by 24. Now remember, you can multiply by anything you want. 8's fine, 24's fine, 97's fine, it doesn't make any difference. You're allowed to multiply through an equation by any number you want. This case though, when I multiply by 24, this cancels and leaves me with 3t plus 15. Do you see that? This cancels, and watch it now. This would be minus 12t plus 24 equals 8. And now I have no fractions to mess with. So I have negative 9t plus 39 if I just collect like terms. Keep an eye on my arithmetic, please. And I have negative 9t equals negative 31. I got 31/9 as my answer. Oh Lord, did I do that right?
Mm-hmm. Yeah.
Got it? Madeline?
49.
49 is exactly the same scenario, except it's an inequality. You are allowed to multiply in an inequality, just like you do in an equation, as long as you remember that if you multiply by something negative, you have to switch your sign. So did I copy that right?
Yeah.
Talking and writing is hard.
You don't have to do that when I did it. Don't you multiply by?
Multiply everything by 12.
Yeah.
Would it be completely wrong?
I can't stop. I gotta finish it. So that would be 3x minus 15 plus 12 minus 8x is less than negative 24. So negative 5x minus 3 is less than negative 24. Well, keep an eye on my arithmetic, please. So negative 5x is less than negative 21. Ooh, and x is greater than 21/5. Did I make a mistake?
I got that, but
It's entirely possible I made a mistake.
no, I see what I did.
Would it be wrong if I got like a common denominator for both of them and then just added and then multiplied?
Absolutely.
That's okay.
That is never a problem.
Okay.
Never a problem. You better have gotten the same answer.
I did, yeah.
Never a problem to do that. You can always do that.
When it's saying to like find if an equation is linear or not, like on number 9, I don't know how. I was kind of
Okay,
confused.
did we not go through what makes things linear yesterday? Maybe we did. Who knows? There are some rules about linear equations. What are you doing on that iPad? There are some rules about linear equations. Did we talk about any of those yesterday?
Just the
Yeah, what did we say? What did we say? Well, y equals mx plus b, yeah, that's the format of a line for sure. But in terms of being given an equation and somebody saying, is it linear? I guess one way you could think about it is, can you make it look like y equals mx plus b? That would tell you it's linear. It will never be linear though, if it has an x in the denominator. You can't have an x in the denominator. It will never be linear if it has powers bigger than 1. And it will be it never will be linear if it has the square root of an x, or a cube root of any radical of an x. If you graph the square root of x, you will not get a line. If you graph an x squared, you won't get a line. And if you graph 1 over x, you won't get a line. So you can't have variables in the denominator variables under the radical, or variables raised to powers bigger than 1. If you have any of those things, it is not a line. So when you look at your problems there, anything with a square root of x, out. Anything with an x in the denominator, out. Anything with a squared or bigger, out. That's how you do it. Okay? All right. Who else? Anybody else?
Maybe 3.
3? 3 says the square root of 1 minus x squared plus 2 equals 3. So this is number 3. My job is to check -2, 0, and 2. Want to know which one of these works. So I'm just going to plug them in. So I'm going to plug in -2. What's -2 squared? 4. I think we have a problem here. What's 1 minus 4? This is going to have i's in it, right? Okay, so that doesn't work. Okay, 0. What's the square root of 1 minus 0? Plus 2? I think that one works. 2, well, 2's not going to work because it's going to be the same as this, isn't it? If you wanted to solve that equation, now remember, our job wasn't necessarily to solve it. Our job was to check these answers, which one works. But if you wanted to solve this equation, what would you do first?
Subtract.
And then what would you do? Very good. Right? So we subtract 1. So x squared equals 0. What's the answer to the question? 0. Which is what we discovered, right? That was the only one that worked. All right.
You do 34 stuff.
34, what's going on there? Which ones are solutions? So it's kind of the same thing, only this time we're checking it in an inequality.
It is.
And we're checking -1, 0, and 2. Okay, so if we just check it, we put in -1. What are we going to get here if we put in -1? 1 plus, well, no, we're putting in -1 for the x, so it'd just be 1 plus 2, which is 3. Okay, so then we got to decide, is that a true statement? Is it true that -3 is less than or equal to 3 is less than or equal to 3? Is that true? Yep, so that one works. Okay, now let's put in 0. Put in 0, we have a 1 here, right? Is that a true statement?
Yes.
Let's put in 2. Is that a true statement?
Yeah.
I think they all work. Now, you could, just like we just solved this one, you could solve this if you wanted to do it that way. How would you go about solving this if that was the method you chose?
Subtract 1.
I would subtract 1 from everything. So that would leave me with -4, -2x, and 2. Okay, then what? Divide by -2.
So you have to flip both this up.
Where everything's going to switch. It's going to be 2 greater than or equal to x greater than or equal to -1. So what that means is, this is kind of backwards, means x is bigger than or equal to -1 and less than or equal to 2. So aren't we talking about this set of numbers right here?
Yeah.
Do these answers fall in that shading? That's why they're all answers then. Okay? All right, tomorrow we shall have a quiz or two of some kind. I hope we will be prepared. Today we are going to finish up our discussion of lines and start a little bit in with,
Would be good to cover P1, P2, P3.
that will be over everything we've ever talked about. Yesterday, we pretty much wrapped up our conversation about lines, gave you a couple challenge problems, which you did a great job with. Let's just review that real quickly. Let me give you a couple of points. Let's say point M has coordinates -3, 4, and point N has coordinates 1, 2. And we're going to write the equation of line MN. Now, everybody in this room better know how to do that. Step 1. Talked about it yesterday. Find the slope. And how are we going to find the slope?
Y.
So 4 minus 2,
-3 minus 1.
-3 minus 1. That gives me a slope of -1/2. Very good. Step 2. Pick a point.
Yeah, point slope.
And you're either going to use the point slope form or the slope intercept form, right? Whatever you want to do. So you're going to use this slope and one of these points. I'll choose this one because there's no negatives in it. And we're going to write the equation of our line. So I will do y minus 2 equals -1/2 x minus 1. Some of you may do 2 equals -1/2 1 plus b. Either strategy is fine. This is y equals mx plus b. Either way you go, your answer will turn out to be -1/2 x plus 5/2, or 2.5. Everybody okay with that? Now, what if I asked you, we talked about this yesterday, to write the equation of the line perpendicular to 2x plus 3y equals 5, and containing 1, 2.
Don't you just use that and then do the opposite?
So you have to find the slope.
You have to
So I gotta find the slope of this line.
So put it in Y.
So how do I find the slope of a line? I gotta put it in y equals mx plus b form, right? So 3y equals -2x plus 5, and y equals -2/3 x plus 5/3. So the slope of this line is -2/3. So the slope of the line I want is 3/2. So I'm gonna use 3/2 as my slope. Because what's the deal here? Opposite reciprocal slopes. Perpendicular lines have opposite reciprocal slopes, right?
Yeah.
Okay, and it contains the point 1, 2. So now you take this slope and this point, and you do one of these things, right? So y minus 2 equals 3/2 x minus 1. So y equals 3/2 x minus 3/2 plus 2. How about 3/2 x plus 1/2? Does that sound about right?
Yeah.
Everybody okay with that? All right, one more challenge problem, and then we're gonna look at the next set. Write the equation of the line. Containing -2, 3, and the point of intersection. of 2x plus y equals 4 and 3x minus y equals 7. Okay, I'm open for ideas. And Ravili, how can you yawn in the middle of this problem? This is exciting. What are these two things? Those are, well, they're equations for sure, but what are they if I graph them? They're lines. So these are two lines, right?
Yeah.
So here's the situation. These two lines are out there crossing.
Yeah.
There's this other random point out here. And that's the equation we want to write. So we need to write the equation line through these 2 points, right?
Yeah.
So what's the first thing we're going to have to figure out? What's that point of intersection? You know how to do this. How do you find where two curves, lines in this case, cross each other? You know this. It's the biggest part of the ECA, Algebra 1 ECA. What?
You make them equal to each other?
Make them equal to each other. What do you mean?
Make them equal to y and then they switch it.
What do we call that? Substitution. We either use substitution or elimination. Now, my personal favorite is elimination. If given a choice, I'll eliminate every time. You were talking about substitution. Make both equations y equals and then set them equal to each other. That's called substitution. It will accomplish the same goal. We need to figure out what point both of these have in common. So I am simply going to line them up on top of each other. When I add them, I get 5x equal to 11. Kids, you remember doing this?
Yes.
Zillions of times. So x equals 11/5. So this point has an x coordinate of 11/5. How do I find its y coordinate? Plug it in. So I'll just plug it in the top one, I guess. So 2 times 11/5 plus y equals 4. 22/5 plus y equals 20/5. So y equals -2/5.
Where'd you get the 25th?
25 is 4.
Get a common denominator. Now what? Now I'm going to find the slope. Oh my goodness gracious, we got fractions all over the place. That's what happens in real life. So here we go. What's our slope? 3 plus 2/5. I'm actually subtracting 3 minus -2/5. And -2 minus 11/5. That's completely up to you. I'm going to multiply everything by 5. So I'll have 15 plus 2 over -10 minus 11. That's easier for me to manage. I'm simply going to multiply everything here by 5. And I end up with 17 over -21. Lovely. Now what?
Write the equation.
I'm going to write the equation, probably use this point. So y minus 3 equals -17/21's x plus 2. almost more than I can handle. I got 29 21s, was that right?
Yeah, you're right.
That was 34. I had to add 3, which is 63. So negative 34 and 63 is 29. Got it?
Yes.
Arithmetic's kind of bad, but that's okay. That's all right. We're big kids, we can handle it. All right, now we need to talk a little bit about a couple of things. We're gonna need a calculator tomorrow, people, so if you don't already have one, borrow one or something, get one so we'll have it for tomorrow. We're doing some graphing tomorrow. Oh, before I forget, make sure your name's on your homework and pass it up. I want to go through your homework tonight. Make sure your name's on it. You guys did that. You passed it up. Okay, today we're going to spend a couple of minutes. We'll finish this discussion tomorrow. We're going to spend a little bit of time with quadratic equations today.
Did you do 16 with the chamber?
So, when I throw this quadratic equation up here, first of all, gang, what do I even mean by quadratic equation? Not linear anymore, it's quadratic. What do I mean by quadratic equation? It's got a square. So when the degree of the equation is 2, in other words, when your highest power is x squared, you have a quadratic equation. We love mathematics because there's always options. What are the options to solving quadratic equations? Completing the square. So let's make a list here. Somebody said we can complete the square. What else can we do?
Quadratic formula.
We can use the quadratic formula. What else can we do? What? I think somebody said it. Yeah, you can put it in bold, that's great. You can factor it, right? Now, this one and this one will always work. Factoring doesn't always work. You probably know that from your experience, right? This one does factor. So I am going to do this problem all 3 ways. That will be our practice with all 3 methods. Okay? This one does factor. So when I say factor, I mean split it up into 2 parentheses and kind of unfoil it. Because foiling would mean getting rid of these parentheses, right? And creating that. We're going to undo that foiling. So I know that I'm going to have an x and an x here. How do I know that? Because when I FOIL it, I got to get x times x, I got to get x squared, right? Now, also when I FOIL it, whatever I put here and here has to give me 5, negative 5. I don't have many options, right? Plus 5, minus 1. Now, it could also be minus 5, plus 1. So you have to pay attention to those signs. My objective is to end up with a 4 when I do my foiling. Do I end up with a positive 4? Yeah. So this is the factorization. Now, the directions didn't say factoring. The directions were to solve this. So there's a step that comes after this.
Set to 0.
Set each factor equal to 0. You're big kids, you don't have to write this step down. The answers are negative 5 and 1. How many answers does every quadratic equation have? 2. 2. Always 2. Now, once in a while they're the same, like you might get 5 and 5, but there's always going to be 2 answers generated. All right, let's do the same problem by completing the square. Do you remember your process for completing the square?
Add 5.
Yep, when you complete the square, you gotta move this guy to the other side.
Squares.
Now, it's not a factor in this problem, but I wanna make sure I talk to you about it. When you complete the square, this coefficient right here has to be 1. So if the problem had had a coefficient there, in addition to moving the 6 over, you would also have to divide everything by 2. You cannot have a coefficient on x squared if you're completing the square. It's fine here, it's fine with factoring, but you can't have it when you complete the square, so you've got to divide it out. Alrighty? Okay, we didn't have that. All right, so what's the next step? After we get this coefficient taken care of and this constant moved over, what do we do now? Divide 4 by 2 and square it. So half of 4 is 2 squared is, and we add that to both sides. Does that sound familiar to you? You take half of this, always this, half of the linear term squared and add both sides. All right, we'll finish this tomorrow. That's almost the line. Oh, this is actually going to be tomorrow night. I told them the lines, you should be able to read the lines.
Here, marker for
Oh, Sharpie.
Says what?
I'm too afraid to set the question.
Have a good day, people.
I never got his name. I was like,
Ready, Carter? And he said that,
I have so many books. I don't remember what
A
it is.
and B and E.
Oh, okay.
It's a huge locker. Half of it. I swear, I'm really relaxed.
Actually, I don't think I'm gonna use my locker. I'm just carrying it around. Really?
What should I do with this crown?
They're really slow. I need to find Suzanne. She has.
You guys have a good day.
You too. I know, I'm always running it. Like badly.
Oh, geez, I bet the big guy's still running.
I want to make some crown. No, that's so awkward.
We gotta remember to turn